Now there are three types of roll radius measurement controls, and basically they are used to control unwind and rewind zones because they measure that radius change as the roll radius either builds or decreases in size. And basically they decrease torque off of an unwind and they increase torque at the rewind. And also the good thing is, because they know radius and they know what the build is onto a rewind, they can provide you with taper tension. But they're never used in internal zones because they literally are just giving you an output relative to roll radius, and we know in internal zones roll radiuses never change. We're just talking about these types of controls are used at the unwind and the rewind. So they are what's called open loop controls. They assume all other conditions are proper. All they're giving you is an output relative to radius. The oldest technology is follower arm, and basically it has a wheel or a roll that lays on the outside of the roll, or on the outside of the roll of your material, and the arm pivots as the roll radius changes. And as that pivoting arm moves, there's a sensor that looks at the position of the arm and gives you an output relative to the position of that arm. And it at the unwind it'll increase, at the unwind it'll decrease torque, and at the rewind it'll increase torque. This is an example, simple example of a lay-on wheel. Basically you have a wheel that sits on the outside of the roll, and as this unwind, if this is an unwind, as it's getting smaller, there's some kind of loading device, usually a cylinder, loads that wheel up against the outside of the roll, and as it's getting smaller, this position sensor sees the position of this arm and tells the control to decrease torque as the radius is getting smaller. And sometimes you'll see these you'll have a roll all the way across the web, a lay-on roll, and at a rewind again you can see as this arm would change position, and let's say at the rewind, as it's getting larger, it's going to tell this control to increase torque. Some advantages: they are pretty simple. They are a good replacement of manual control. So if you have an operator, adjusting a pod or adjusting a regulator, this type of control is a good replacement for that. Relatively inexpensive, relatively easy to install. You just have to install the wheel or the pivoting arm mechanically into your machine. Some disadvantages: if you have rolls that are egg-shaped or aren't really completely round, you can get a lot of oscillation from these types of sensing devices because that arm is constantly moving, so the sensor is always moving, which will make your control always move and give you some oscillation. The biggest disadvantage, I think, to this type of control is the lay-on roll or lay-on device, whether it's a wheel or a roll, is always in the way of roll changes, because on an unwind, when you completely expel your roll, you have to move that arm out of the way to get a new roll into your machine. They do require modification if you want to change the capacity of the unwind. You mechanically have to make some changes to the control device in order to be able to run bigger rolls, let's say. They do have some mechanical parts that do require maintenance from time to time. They're really, again, because they're open loop, they can only control unwind or rewind zones. And they do contact the outside of your roll. Some materials may be sensitive to that. Some materials you may not want to touch the unwind or the rewind.